What's going on, guys? Let's look at this problem right here. Here this question is asking, show y1 is equal to 2t minus 1, y2 is equal to t square plus 5, y3 is equal to 4t minus 7 are linearly independent on negative infinity to infinity. Now to show this is a linearly independent, we have to show something like this. We have to show if c1 y1 plus c2 y2 plus c3 y3 is equal to 0, then c1 is equal to c2 is equal to c3 is equal to 0 is the only solution. That's what we have to show. Okay, now let's see whether we can show this for this one. To show that one, what we have to do is, we have to, here you can see this y1 y2 y3 are multiplication of constants, and we equate that one to 0, then we have to prove this one. Okay, now let's go ahead and do that. First, c1 multiplied by 2t minus 1 plus c2 multiplied by t square plus 5, and then c3 multiplied by 4t minus 7, the whole thing is equal to 0. Now here, if this whole thing is equal to 0, here this one has to be 0, then this one has to be 0, and this one also has to be 0, then only we can get 0 as a solution. Okay, now let's go ahead and continue. Here I'm going to compare the coefficients. Here we have t square terms, and we have t terms, and we have constant terms. So we can combine these, we can separate these terms. Here we have t square only with c2, that is c2 t square, and then we have t terms, that is first one is c1 2t. So I take this c1 common, and this is going to be 2t. Do we have any other t? Here we have 4t, that is plus 4t. I write this one right here, plus 4t. Okay, here it's better to take t common because we have c3 right here. So I take t common. So for t we have 2c1. I write this one first, and here we have 4t c3. So I write 4c3, and then we can take the t common right here. Then we have constants. For the constant, first we have negative c1, and then we have 5c2 plus 5c2 minus 7c3 is equal to 0. Again, this whole thing has to be 0. This one has to be 0, this one has to be 0, and this one has to be 0 in order to be, the whole thing is to be 0. Okay, now c2 t square is 0. Therefore, if we equate this one, c2 t square is equal to 0, therefore c2 is equal to 0. So this is straightforward. And here we have 2c1 4c3 t is equal to 0. Let's write these two things. 2c1 plus 4c3 is equal to 0, and we have negative c1 plus 5c2 minus 7c3 is equal to 0, and we already know c2 is equal to 0. So instead of writing 5c2, I can just neglect that one and write this 7c3 right here, that is negative. Okay, I put negative 7c3, that is equal to 0. Now here we have two terms, so to eliminate one of the terms, I multiply this one by 2. If we multiply this one by 2, we are going to get the top one remain the same. 2c1 plus 4c3 is equal to 0, and the bottom one will become negative 2c1 minus 14c3 is equal to 0, and if we add them together, this is going to be 0, and this is going to be negative 10c3 is equal to 0. Therefore c3 is equal to 0. So we have c3 is 0. If c3 is 0, then we can plug it in this equation. If we plug into this equation, this is going to be 2c1 plus 0, because 4c3, 4 times 0, that's going to be 0. So 2c1 is equal to 0, therefore c1 is equal to 0. So finally we found out that c1 is equal to 0 and c2 is equal to 0. When this whole thing is equal to 0, we found out that C1 is equal to C2 is equal to C3 is equal to 0. Therefore, the given three functions are linearly independent, and that's how we do that. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.